Hello viewers, this is Professor Anand. So in this video tutor we are going to see the portal frame analysis. As now we need to follow the similar procedure. The file name has to provide in the new project as a portal frame, and choosing the location where we are going to save the files, and confirming the units, force and length units, and finish it off, and closing this default grid liner, and we need to create a model. So the model is a 3 meter height, 4 meter span, and backside 1.5 meter. So now from the 0 coordinate we are going to start the modeling from 0. 3 meter height, it is in y direction, right? You can see here, and in the x direction it is 3 meter, and it is in the y direction it is 4 meter. As you can we need to see in the problem statement that in the x direction it is 4 meter, in the y direction it is 3 meter height. So now we can see, and again as we have seen in the problem statement, it is in the back side we got 1.5 meter length from the 0, since it is minus 1.5, because we are entering from the 0, and which is at 3 meter height, adding all the nodes to form a structure. Now we can see which is in the same form what we have observed as a problem statement. The height is 3 meter, length of the beam is 4 meter, and backside it is 1.5 meter. In the problem statement what we have, the similar dimensions we are just cross verifying here, right? One end is fixed and other end is also fixed here. So before that we have to go to the general. In that general we need to check or assign the sectional property. I am taking here 0.35 by 0.23, adding it, and I will assign this to the beam, and so that I can create one more for column, which is 0.4 by 0.23. So which I am making it for column, and I will choose the column and I will assign it, and I will take another section for beams, and I will assign both the selected beams here. Now you can see R1 is the first section, R2 is the second one, and the support condition what we have observed from the problem statement, which is both are fixed end. So I will take only support end for fixed one, and I will take 2 nodes to assign it, right? As you can see here, there are 2 ends. So for these 2 ends we are going to assign the fixed end support. So the next step is to go to the load cases. So load case is the uniformly distributed load of 24 kilonewton meter, and 2 concentrated forces are acting on the 2 different spans. So first load case, I will take it as a dead load, which is dead load case. The title is given, and I will go to add it, and I will go to the live load case, live load, add it, right? So here in the load case I will need to take the combination. So I will take the factor as 1 for both live load and dead load. I will take it as combination, and including the load case, the self weight is the dead load, and in the live load I am going to take 1 UDL load and 2 concentrated loads. So uniformly distributed load, as you can see in the problem statement, it is 24 kilonewton per meter, so which is acting in the downward direction, minus 24, which is on the whole span, so no need to enter D1, D2. So one is concentrated force and another one is horizontal concentrated force. So concentrated force of minus 10 kilonewton which is acting at the end, and another concentrated load minus 12 kilonewton. As you can see, this is minus 12 kilonewton load acting at the center, right? So center it is 3, as it is a 6 meter span. So I'm going to assign the self weight of the structure for the dead load case, and uniformly distributed load on the span, selected the span and assigning it. So make it to the visible in the load values. Yes. So now I am going to apply this concentrated load on the span. I am assigning it. So since it is acting at the center, now in the section we got it is acting at the zeroth point, means at the starting point, which is in this starting point is minus 1.5 here. Sorry, it is 1.5 here. It is 1.5. From the 1.5 it is acting here as it is in the problem statement. And the next load which is acting on the span, we'll check it, minus 10 kilonewton load which is acting. Save the files which is modified, save it. Checking that another the concentrated force which is minus 12 kilonewton, I can see 12 kilonewton it is, yes, which is 12 kilonewton, and acting at, since the height of the column is 3 meter, it is at the center it is acting, so 1.5. In the x direction we can say I am going to assign it and assign to the selected beam. So now we can see the forces are acting on the different elements, and now the load values are this one. So now we have come across the actual problem statement, and we have created the model here. So we can see the span of each element are representing the same picture. Right now we are taking the picture for the report and going to analysis. Now the analysis is done. Run analysis has to be run. So now we can see the 0 errors are there. Then we can go to post processing mode, applying the loads. These are the bending stresses because of the live load, we can see, and the results are seen from the result v values and bending stresses and maximum and midpoint. Take the screenshot of this one, and again switching off the bending moment and switching on the shear force. The shear force values are seen from the result v values, shear at end, maximum and mid span. So these are the shear forces on the section. Okay, taking the screenshot of that and generating the report, sections, supports, primary load cases, and the load combinations. These are all the inputs, and the output we can take all the 3 pictures which we have taken, and going to take the printout which is in the PDF form, and we have to save the file where we have created the folder. In that folder the output of the analysis is saved. Thank you.